Hello everyone. This video is going to be the formal introduction to redox reactions. I will be defining what a redox reaction is, as well as giving you some of the key terminologies and concepts relating to a redox reaction. And this is effectively dot point 13.1. So let's start with an example that you have seen before, which is the reaction between an acid and a reactive metal. And this is the actual reaction that you did in class between magnesium and hydrochloric acid. And this is just the full equation. And you can see that when these two substances react together, the reaction will produce magnesium chloride or salt and hydrogen gas. And this is where the pop comes from. Now, if you remove the spectator ions, which are chloride ions in this case, you're going to have this as the ionic equation. So just magnesium plus protons, or H+, going to Mg2 plus and hydrogen gas. And I think it's quite clear here that this is not an acid-base reaction. The magnesium hasn't received the protons from the base. Instead, what actually happens is that the magnesium has lost 2 electrons to become Mg2 plus. And at the same time, the hydrogen ions have gained 2 electrons, 1 per ion, to become hydrogen gas. So the 2 electrons that were lost by magnesium basically has just given these 2 electrons to hydrogen ions. So that's where the hydrogen ions get its 2 electrons. So what actually happens in this reaction is you don't have a flow of protons, but you have a flow of electrons. Electrons were donated away by magnesium and received by hydrogen ions. And a reaction that involves a transfer of electrons or a flow of electrons is called a redox reaction. So this is a definition, just a reaction that involves a transfer of electrons. And there are also specific names for each process. So the donating or losing of electrons and the accepting or gaining of electrons. Reduction is defined as the gaining of electrons. So it's the process of gaining electrons, and you could remember it as there is a reduction in charge since you're gaining electrons, which are negative. And oxidation is the losing of electrons, which will cause an increase in charge. So in a redox reaction, one substance will reduce in charge and another will increase in charge due to the transfer of electrons. So we go back to our example. Magnesium has lost 2 electrons to become magnesium 2 plus. So this process is actually oxidation. And hydrogen ions have gained 2 electrons to become hydrogen gas. So this process is reduction. So that's oxidation and that's reduction. Now the next part can be a little bit, we'll see. So very similar to an acid-base reaction. So we defined an acid as something that donates protons and a base as something that accepts protons. We're going to introduce some similar terminologies to define the substance that gain electrons and the substance that lose electrons. So reduction is the process of gaining electrons. The substance that causes something to gain electrons is called the reducing agent. So the reducing agent, or you may have heard the reductant, is defined as the substance that causes something else to undergo reduction. Now, the reducing agent causes things to be reduced, but it is not going to undergo reduction itself. So the reducing agent actually undergoes oxidation by itself. And then similarly, the oxidizing agent or the oxidant is the substance that causes oxidation in something else. So the oxidizing agent does not undergo oxidation, it actually undergoes reduction. So if you want to keep it simple to remember, oxidizing agent undergoes reduction, reducing agent undergoes oxidation. Don't blame me, I didn't come up with these terminologies. So if we go back to our example, magnesium is the substance that undergoes oxidation, so Mg is going to be the reducing agent. Or you can say that magnesium, because it undergoes reduction, it is able to give 2 electrons to protons, so it causes the protons to reduce. Hence, magnesium is the reducing agent, and hydrogen ions or protons is going to be the oxidizing agent. So the oxidizing agent undergoes reduction, and let's just write, that's supposed to be a U. So undergo reduction, and the reducing agent undergoes oxidation. Okay. So let's just summarize what I just said once again. So a redox reaction is a reaction that involves a transfer of electrons. So this is another way that you can visualize the process. There will be two reactants. One reactant gives away the electrons, the other accepts the electrons. The process of losing electrons is called oxidation, and the process of gaining electrons is called reduction. Now, the substance that donates away the electrons and causes something else to be reduced, that substance is called the reducing agent. So the reducing agent donates electrons and undergoes oxidation. The substance that accepts the electrons and undergoes reduction is going to be called the oxidizing agent. So that's a summary of all the terms that I've just given you so far. All right, one more term, conjugate oxidizing reducing agent pair. And this is going to be very, very similar to the conjugate acid-base pair, except that the members of the pair don't have to differ by one electron. It can be one or more. It really depends on the reaction. So in this case, let's just recap what we just did. The process of Mg going to, I think I'm going to write down here, Mg going to Mg2 plus. So this is the process of losing 2 electrons, and it's also called oxidation. Mg is the reducing agent, which undergoes oxidation. So Mg2 plus is going to be the conjugate oxidizing agent of Mg. So there is a potential for Mg2 plus to undergo reduction and then gets returned to Mg. So Mg2 plus is the conjugate oxidizing agent of Mg. Similarly, when you go from H plus to H2, this process is reduction. So this is reduction, which is gaining 2 electrons. And H plus is called the oxidizing agent, which means that H2 is its conjugate reducing agent. So conjugate reducing agent. So it actually behaves in a very similar manner to an acid-base and conjugate acid-base pair of H plus. Okay, so that's conjugate oxidizing reducing agent pair. A reducing agent is going to produce its conjugate oxidizing agent, and an oxidizing agent, it's going to produce its conjugate reducing agent. All right, let's just go through one example, and then we'll do some more questions next week in class. So this example asks you to identify the oxidizing agent, the reducing agent, and the conjugate in the following equation. So this is the equation. Now this is the rusting of iron. So iron reacting with oxygen to produce iron oxide. That's actually just a redox reaction. And what you're going to have to do is you have to think of this as an ionic compound. So it actually contains Fe2 plus and O2 minus, except that it's in solid form, so you can't really dissociate them. It's not dissolved in water or anything. But what actually happens is the Fe has lost 2 electrons to turn into Fe2 plus, and then at the same time the oxygen has gained electrons. Well, technically the Fe has lost 4 electrons because we have 2 Fe going to 2 Fe2 plus. And the oxygen has gained 4 electrons to go from O2 to 2 O minus. So if you look at this, Fe has undergone oxidation. So this process is oxidation. It has lost electrons, and the oxygen has undergone reduction. So the oxidizing agent, it's going to be oxygen. The substance that undergo reduction is the oxidizing agent. So the oxidizing agent is O2, and the reducing agent is Fe, which means that the conjugate, so O2 minus is the conjugate reducing agent There has to be a shortcut for this. Not really. Conjugate reducing agent of O2 is going to be O2 minus, and the conjugate oxidizing agent of Fe is Fe2 plus. Okay. You get better with practice. Now it's just a matter of remembering the terminology. So that's the first video.